Okay, next assignment. You guys, I don't think will be real impressed with this one. This kind of seems pointless, a lot of it, but here we go. Okay, you'll need graph paper for these first three examples. It says, how is each function related to y equals x? Graph the function by translating the parent function. Okay, here I'll write the directions up here in graph paper. How is each function related to y equals x? Graph the function by translating the parent function. Okay, first off on the graph, you have to graph y, and the first question says y equals x minus 2. First off, you start with y equals x, so if you set x equal to 1, so y would equal 1, so you just go forward 1, up 1. If you set x equal to 2, which is where I'm at here, then y equals 2, so 2, 2. So all the coordinates are essentially the same, so 3, 3. If you set it equal to 0, you're at 0, okay? If you go x is negative 1, well then y is going to be negative 1. And then the same with negative 2, and that's probably good enough. We get the idea. Okay, so you graph those points, make a line as straight as you can. Now, if you notice your points, you go up 1, forward 1, up 1, forward 1, just repeatedly, okay? Because every time x goes up by 1, then the y is going to go up by 1 with it. Now, x minus 2, here's what you do for a translation. Take the middle, the origin, and just translate it down 2 units, okay? So down 1, 2. And then you repeat the same process. So up 1 over 1, up 1 over 1, okay? And then the lines go like that. They'll be parallel to one another. That's all you do, okay? Okay, next one, y equals x plus 3. So if my parent function is y equals x, that doesn't change, okay? That's a parent function of a line. Okay, so y equals x, so I go forward 1, up 1. 0, 0. If x in the parent, I'm graphing the parent. If x is 0, then y equals 0. If x is 1, it's going to say y equals 1. If x is 2, y equals 2, and so forth, okay? And that's your parent function of a line. It starts in the middle, up 1, over 1, up 1, over 1. Okay, then plus 3 means every point's translated up 3. So let's just take the origin, translate it this up 1, 2, 3, and then just up. And there you have it. Pretty exciting. Okay. Next one, y equals x minus 5.5. Okay. So again, the parent function of a line is y equals x, okay? So that's your line. Then we're going to translate the origin and every other point with it down 5.5. So down 1, 2, 3, 4, 5, 5.5. Then up 1 over 1, up 1 over 1, up 1, and it just keeps on going, okay? That's how you translate parent functions of a line. Pretty exciting, okay? Now the next problem you can do in your notebook, make a table of value, make a table of values for the function of x, that's what that means, after the translation. This is easy too, even though how pointless it may seem. So the first problem says 2 units down. Okay, so x, f of x is just another way to write y. I know you guys are going to think that's kind of dumb. Why would you write that when you can just write y? They're overcomplicating it, and I don't disagree, but it does come up. 2 units down means you don't translate the x. 2 units down means you just make the translation for the f of x. So 2 units down, you just subtract 2 from all these. Okay. So our new table is -3, -1, 1, 3, and then 4 minus 2 is 2, 8 minus 2 is 6, 12 minus 2 is 10, 16 minus 2 is 14. And that's the answer right there. Okay, next problem, 5 units up. So x, f of x. So x, the original function, is -3, -1, 1, 3, 9, 1, 1, 9. Okay? Well, 5 units up means we just add 5 to the function output. Okay? So we have x, f of x. So -3, -1, 1, 3, 9 plus 5 is 14, 1 plus 5 is 6, 1 plus 5 is 6, 9 plus 5 is 14. Now that is still a function, okay? Because you don't have any, this is your domain, you don't have any repeats there. You can have repeats in the range and still have a function, okay? Okay, that's the end of that. Next, it says write an equation for each vertical translation of y equals f parentheses x. So write an equation for each vertical translation of y equals f of x. You're like, I have no idea. The first one says 1/5 units down. All you're doing simply is adding or minusing 1/5 because it's going down. Okay, you just write y equals f parentheses x, and then after the function you just minus 1/5 from it. It's essentially what you're doing here, just you don't have the table. Okay, next one says 3 units up. So y equals f function of x. 3 units up means you just add 3 to all your outputs in the function. Okay, 6 units down. Y equals f of x minus 6. So essentially you just think of that as your parent function there. You're just adding and subtracting up, down. Now, sometimes it's going to say left or right, but we'll worry about that when it happens. Now, it's back to the graph paper for the next examples. For each function, identify the, here I'll write down, for each function, identify the horizontal translation of the parent function f of x equals x to the second power. Okay. Alright, so here's what you're going to do. Here's the first problem. Y equals parentheses x plus 3 to the second power. Now the parent function is just y equals x to the second. We're going to graph the parent function first. I'm going to need a table for this because it's not as simple as when it just said y equals x. Now it's y equals x squared. I'm going to go 2, 1, 0, -1, -2. So if I put 2 in for x, 2 to the second power is 4. It's not, so y actually changes then. If I put 1 in, 1 to the second power is 1. If I put 0 in, 0 to the second power is 0. -1 to the second power, it's not -1. If you take -1 times -1, that's +1. So that ends up back at +1, and that ends up at 4. This is the parent function. Okay, I'm not going to write it every time, but it's 2, 4, 1, 1, 0, 0, -1, 1, -2, 4. Okay, so let's graph the parent. So 2, 1, 2, 3, 4. 1, 1, 0, 0. Negative 1, 1, left 1, up 1, left 2, up 4. Okay, that's the parent. This is called a parabola. If you had Algebra 1 last year, you probably haven't seen that unless say you got to it in 8th grade, because the shutdown happened before I could get to it. Okay, this is what you do with the translation though. This time, the plus 3, see up here in these original problems, the first ones we did, there was no parentheses, okay? When there is a parentheses, it's a horizontal shift. It's not going to be just going up or down, okay? Whenever the plus 3 or minus whatever is grouped in a parentheses in an absolute value, whatever, you're thinking left, right, and you're thinking opposite, okay? So normally I think a plus 3 is this way, but I need to do the opposite of plus 3, which is this way, 3. Okay, that's the translation. So translate every point this way, 1, 2, 3. And I would like you to plot that point negative 3, 0, and it'll make more sense, and here's why. Because if I put negative 3 in for x, negative 3 plus 3 is 0, and 0 to the second power is 0, which takes us exactly to where we want to be, okay? So inside of the parentheses, you translate it left to right, but you do the opposite of what it says. So if that was a minus 3, I'd be going right 3, but when it's plus 3, I do the opposite, okay? Inside. That's how horizontal translations work, okay? When it's in the parentheses, inside of the grouping symbol, which in this case is a parentheses, it's a left-right translation. Here there were no parentheses, so it's up-down, okay? But here when we have it inside of a grouping symbol, it's left-right, and it's the opposite of what it appears to be. Plus 3, so we go this way, 3. It's like you're undoing the plus 3, okay? So you can get back to 0. Which negative 3 plus 3 is 0. 0 to the second power is 0. So it takes me to 0. Okay? I'm going to plot the 0, 0, 2. That's the parent, the y equals x squared. Now if I put negative 3 in for x, negative 3 plus 3 is 0. 0 to the second power is 0. So the y's should match up when you do that. See, if you did right 3, 3 plus 3 would be 9. 9 to the second power is 81. That does not get me back to 0. So that's why it's opposite. Okay, then I graph them the same way. So here's how you can do it. You're going to go right 1 up 1, left 1 up 1, just like this appears, okay? Then connect them. Then from these points, okay, go back to the middle, okay, go back to the middle, and you're going to go right 2 up 4, okay? So right 2 from the middle, right 2 up 1, 2, 3, 4. Left 2, 1, 2, 3, 4. Okay. So right 2 up 4. Okay, so then that's what you have. Okay. Next one. Y equals x minus 5 to the second power. Okay. The parent, again, we're using y equals x to the second. Because that's the parent they gave us up there. So again, our parent function, I'll just make a table for the parent every time. 2 to the second's 4, 1 to the second's 1, 0, 1, 4. Okay, graph the parent. So 2, 1, 2, 3, 4. Okay. 1, 1, 0, 0. Left 1 up 1, left 2 up 4. Please label the origin in the parent 0, 0. Okay, so x minus 5 equals 0. Remember, when that minus 5 is in the grouping symbol, then it's a horizontal left-right translation. And minus 5, I normally think of left, but I have to go to the right. It's like the opposite, so I go right 5. So I go right 5 from the origin. 1, 2, 3, 4, 5. And now it's 5, 0. Because if I put 5 in for x, 5 minus 5 is 0. 0 to the second power is 0. Then do your thing, go 1, 1, then go back to the origin point and go 2, 1, 2, 3, 4. 2, 1, 2, 3, 4. Okay, and there's your transformation. Next one, y equals parentheses x minus 2 to the second. Again, the parent function y equals x squared. So the parent function behaves like this. We'll just go same thing, 4, 1, 0, 1, 4. So 2, 1, 2, 3, 4. 1, 1, 0, 0, negative 1, 1, negative 2, 4. Okay, there's your parent graph for y equals x to the second. Now minus 2 is in the parentheses, so it's left, right instead of up, down. Now minus 2, you'd think this way, but it's the opposite of minus 2, so you go to the right. Okay, so we transition it right to, labeled as 0, 0. So right 1, 2. And now it's at 2, 0, which makes sense because if I substituted 2 in for x, 2 minus 2 is 0 to the second power 0. See, if I go left, that's wrong because negative 2 minus 2 is not 0, it's negative 4. Okay, then 1, 1, 1, 1. You run into a point that's already there, that's okay. And then go back to the origin, go 2, 2, 3, 4, 2, 4. Okay, and those are your parents. That's the parent in the middle, the transition goes over that way. Okay, now we go back to the notebook. Write a function rule for each function reflected in the given axis. Okay. Okay, the first one says f of x equals x minus 6, and it says x axis. Okay. Now here's what it means by x axis. That means don't draw this table. This is just an illustration, so I'll do the 2. If I put 2 in for x, 2 minus 6 is negative 4. If I put a 1 in, negative 5. If I put a 0 in, negative 6. If I put negative 1 in, negative 1 minus 6, negative 7. Negative 2 minus 6 is negative 8. Now what reflection the x-axis means is we need some way to translate this equation so that all my x's become opposite and the y stays the same. Okay, all the x's become opposite values. So we want to write a function where if I put negative 2 in, I still get negative 4. If I put negative 1 in for x, I get negative 5. If I put 0 in, I get negative 6. If I put positive 1, I get negative 7. If I put negative 2, I get negative 8. Here's how to do this, okay? You simply just make your x term into the opposite, a negative, okay? Okay, and that's all that is. That's all that basically entails. Because now, okay, let's see if this works out. I'm going to make all my x's negatives. I'm just going to switch all the x's and then my y's stay the same. Now let's see if that can match up. That's how you check your answer. So if I put negative 2 in for x, okay, there's already a negative there, okay? And you could put a 1 in front of it if you want with the negative, okay? So if I put negative 1 times negative 2 minus 6, it's going to be 2 minus 6, negative 4. Now if I put negative 1 in for x, negative 1 minus 6, that's going to be 1 minus 6 is negative 5, and so forth. This is the answer right here. All you do to reflect the x-axis is simply make the x term into the opposite, okay? Basically, that's all you had to do right there, make your x term opposite. Okay, next one. F of x equals 3x. Here, I'll block it off. You don't have to do all those tables, okay? And the reflection is in the y-axis this time, okay? So you don't have to make the tables, you can just watch. Okay, if I put 2 in there, the original function, 3 times 2 is 6, plus 4 is 10. 3 times 1 is 3, plus 4 is 7. 3 times 0 is 0, plus 4 is 4. Then you're going to go 1 and then negative 2 is how that's going to work. Now, here's how the reflection, now all the x's would stay the same. We'd want all the x, but the y terms go opposite. So how do you write the function for that? Okay. What you need to do is you are going to change your x term to the opposite, so negative 3, and you change the y-intercept to its opposite, minus 4. Okay. Now let's see if that works. Okay. So I'm going to take negative 3 times 2 minus 4. Okay. Hopefully I get negative 10. I do. Okay. Negative 3 times 1 minus 4. I got negative 7. That's all going to work. So that's your answer. This is all you need to write. Negative 3x minus 4. So to make a long story short off all that, if it's translated in the x-axis, you just make the x term into its opposite. Y-axis, everything goes to its opposite. Okay, so let's simplify that a little bit without making all those tables. And I just proved that it works. So y-axis. Y-axis, you make everything into its opposite. Well, the only thing there is the 5x, so negative 5x. That's your answer. Okay, next one, f of x equals 2x plus 4. If there was another number there, like a plus 3, I'd make that opposite too, because it's the y-axis. That means the entire function goes opposite. But if it's the x-axis, then just the x term goes opposite. Y-axis, they both go opposite. Okay, next one's easy. Write an equation for each translation of y equals x. Okay. Now the first one says vertical stretch by a factor of 5. Vertical stretch and compression essentially means the same thing. A stretch means the factor is greater than 1 whole. A compression means it's less than 1 whole. At any rate, you write y equals x, and you just simply apply a multiplier of 5 onto your x. It means everything in the parent function is multiplied by 5. Okay, vertical stretch by 3. So y equals x, apply a multiplier of 3. Okay, vertical compression by a factor of 1/3. Okay, y equals x, we just apply 1/3 in front of the x. Okay, last section. Write a function rule we're going to call it g of x after the given transformation of the graph f of x equals 4x. Okay. Now here's how this is going to work. Okay, the first one says translate 2 units down, stretch by a factor of 5, and reflection in the x-axis. So we're basically just taking this y equals 4x and translate it. So start with the expression 4x. Translating 2 units down means you just subtract 2 after. No parentheses, okay? Parentheses with the x goes left, right, okay? There's no horizontal translations here. Stretch by a factor of 5, so that means just the factor in front of the x we multiply by 5, okay? 4 times 5 is 20, so it would be 20x minus 2. Then reflection in the x-axis, that means you just change your x term to the opposite. If it would have said y-axis, I would be changing both the x term and the y term, but it's just the x, okay? And they want it called g of x, so call it g of x. They don't want to use f of x because that's from the original, okay? So there you go. Next, last one. Compression by a factor of 1/2. Reflection in the y-axis. So the function we're translating is still the 4x. So compression and stretch means we multiply the x coefficient by 1/2. Okay, 4 times 1/2 is 2, so it's 2x. Okay, and there's no translating up or down, so we don't add or subtract anything. Reflection, the y-axis means we just change everything to opposite. Well, since there's only one term, we just change that to opposite. So g of x equals negative 2x. Okay, and that's how that's going to work. Okay, so let's recap before you start your assignment. Y equals x, it's when you graph the straight line, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, you have a line. Then you just translate everything 3 units down. These are easy, you just add 3 to the minus 1. Okay, 2/3 unit down, you just put minus 2/3 after the function. Y equals f of x minus 2/3 and up and down. Okay. Next one, graph of the parent function, y equals x squared. That's 0, 0, 1, 1, but then negative 1, 1, that's when it makes the u, okay, in the middle. Then within the parentheses, you're going left, right, opposite though, okay? So you translate the 0, 0, right 4, then you'd make your u from there. Write a function rule in the reflective axis. Remember, x-axis, we need to change just the x term to opposite. So you can put a 1 in front of your x and make it negative 1x, but the plus 1 remains. Y-axis, we do everything, so there's only one term, so negative 3x. If there's another term, I'd change that too. X-axis, just the x term changes. Okay, vertical stretch, you just write y equals x and apply the coefficient in front of the x, and then the translations. Same with the 4x, up 5 units. No compression or stretch, so we don't multiply. Reflection, the x-axis, we change just the x term. Okay. Compression by 1/8, that means you got to multiply your 4 by 1/8 and reflect in the y-axis, so change everything.